So this is a video on the chi-squared GOF, which stands for goodness of fit, function on the calculator. We have an example of doing a problem like this, and it is about a company who sells products by mail, and they take a look at a number of orders over the course of the week and which days those orders occur. And basically, the idea behind this test would be to find out are the orders evenly distributed throughout the week or not? Or is there evidence, to support something different? So notice that there's the line on the number of orders, and then the next line is expected number. Notice that those values were not there, they're written in. But the idea would be to find what value goes there. We're going to add up all the orders for the week, and it does actually tell us that it's 400. We divide it by the number of days that they're having those orders, which is Monday through Friday. And so if we take 400 times divided by 5 days of the week, we would get 80 orders per day. So if they were evenly distributed, there would be 80 orders a day. So now we want to see how different those numbers are. Not how different is 92 from 80, 71 from 80, 65 from 80, and so on. So what we would need to do is put the values into some lists. So if we go stat and edit, I've got some values in my list. So I'll go to list 3 and I'll put in 92, 71, 65, 83, 89. I double check them. I want to make sure that they are right. And then I'm going to put 80 into each value of my other list. So I'm in list 3 and list 4. Now what I do is I go stat, I go over to tests. Goodness of fit is down at the bottom, the chi-squared. So we're going to press the up arrow, and that's going to take us to the bottom. It's not necessary, but I think it's a little bit faster. And there we have it, chi-squared GOF test. We press enter. And then we want to tell the calculator the observed values are what the company observed, and that is in list 3. And the expected would be what we would expect if they were equally distributed, which is 80 orders per day. So that was in list 4. The degrees of freedom here, it's the number of categories, which in this case is the number of days, which there are 5, minus 1, so 4. And then we just press calculate. So notice the values that it gives us. It gives us a test statistic. That's the chi-squared value that it gives us. It gives us a p-value. It tells us the degrees of freedom, which we already gave it. So the last line there, the CNTRB, is the list of all the contributions for each of the days of the week, their piece of the test statistic. So the 1.8 is actually 92 minus 80 squared divided by 80, which is, if you're doing the test statistic by hand, that's the value that would come out from doing the Monday's value. So if you were to scroll to the right, you can see all the other contributions to the test statistic. Adding those all together is what gives you the 6.75, which is your test statistic, which can be compared using a table, or if you're using the p-value method, you have the p-value method to make your decision. And that's an example of the goodness of fit test, chi-squared GOF test on the graphing calculator.